Right, we've got something a little bit different on the bench today. I've already gone ahead and took this apart, so apologies for that. I just had to get into it. Basically, I did a quick repair and tune up on a RP75 Hacker Super Sovereign the other day. Customer came, picked it up, working perfectly, like really good strong reception, no problems at all. Took it home and plugged it in. Very weak FM for some reason, so I talked it through over the phone and to see if we could get it sorted, but it's come back to me. And what he's also sent me back is his power supply. Now, first thing I did when I got the radio back was use my Hacker power supply, and this is a VP408. If you can see that or not, I'll zoom it in a minute. This is a VP408 Hacker power supply with a variable voltage on the back, so you can run anything from 6 to 18 volts off of this. Plugged mine in, radio's working fine, absolutely no problem at all. It's booming in, FM's fine, no issues at all. So that's strange, because he was adamant that it was really weak on FM. So then I thought, well, let's plug his power supply in, and lo and behold, plugged his power supply in, really weak, very difficult to get any stations on FM, and only the strongest ones coming through. So first thing I've done was measure the voltage on this jack plug. Now again, I've taken this one apart at the moment. I measured the voltage on that one. I was getting 10 volts with it set to 12 on the back. Now these are a little bit random, so that's not anything untoward. I measured mine was just under 12 volts. So I thought, right, probably going to have to put some new capacitors in this. So I took it apart. Well, the other issue with this power supply that the customer wanted me to do was the neon indicator. Well, it turns out that one of the wires was just pushed in there, not actually physically connected to anything. So I'm going to have to probably break this out to get at it, because it looks like it's a sealed unit. But anyway, let's get you in a little bit closer, then we'll have a look at this in detail. So first of all, the neon indicator. As you can see, we have a wire adrift. That was just in there. Now the chap had taken this apart to glue it. Where is it? He has a crack in the casing somewhere here that he's glued. And he thinks possibly he might have pulled the wire when he did that. But the problem I've got is it won't come apart to solder this wire back on, and I might not even be able to solder it back on. It looks like what they've done is they've put this piece in and then melted these tabs over to secure it. You know, this doesn't come apart on the top, doesn't unscrew or anything, and it's actually, if you look at the board, it's on the mains side of the transformer, on I suppose you call it the hot side, the incoming mains side, straight across live and neutral. So I don't really want to go messing with it, I just want to get it right. I have got some neons here somewhere, but I'm not sure what voltage they are, so I'll have a look at those in a minute. But my intention is to snip off these little tabs, pull it out, see if I can reattach this wire. If I can, then I'm going to either silicone or hot glue it back in, and that should seal it. That's one thing. I'm going to check these capacitors. Zoom you out a little bit, I'm a little bit too close there. So we've got 3 electrolytics on this board. There's a potentiometer, 10k linear potentiometer there, which comes out the back here. That could be an issue, I'm not sure yet. I might just need a bit of switch cleaner in it, or I might need to put a new one in if it's not the right resistance. So yeah, 3 capacitors there to change. But the issue is the lead. Now, he sent it up to me initially because it's got the dreaded chocolate blocks on it. So someone's obviously cut it for whatever reason. And I mean, there's only a short length. It's only a short length of lead before you get to the plug. So I mean, what I'm going to do is just reattach these directly to the plug and get rid of this bit. It's going to make it slightly shorter, but at least we've got the original cable. It all looks authentic. But yeah, when I actually took this apart, I noticed that if I wiggled the wire, it would make connection and sound louder. It turns out that we've got a dry joint on the actual pin. If you wiggle it like that, there we go. Not soldered whatsoever. It was just resting in there. Just resting in like that. If you can see that. Yeah, it's just resting in there like that. And then we come to the other end. I mean, look at this. The wire is frayed to hell there. This looks like it's some sort of addition to get the negative on. I don't know if all the hackers are like this. So I'm going to need to remake that or replace it. I'll probably remake it to keep it original. But yeah, that's that. Well, and look at the fuse. Yeah, let's do that now. See what we've got fuse wise. We've got an old style plug here. So really that needs changing for a modern one, so I'll have to do that as well. Amp, so that's all okay. Yeah, it's looking a bit ropey in there as well. Yeah, it's a bit gammy in there. But yeah, dealing with mains voltage, and I'm actually working on it, I'd rather stick with a decent plug on the end of it. So that's the issues that I've got to deal with. So I'm going to get these capacitors out first and just check the ESR of them. Okay. So I've got one side of each capacitor disconnected, so I'm on the ESR meter. This one should be 1000 microfarads. Should be a nice low ESR. $12.27. Yeah, that's not too bad actually. Let's try another one. What's this? 100 microfarads. 117. And lastly, I don't know what this one is actually. 22. 2.2. It's reading 3, so those capacitors are good. Let's not change them. Let's just put them right back on. No point in changing them for the sheer hell of it, really. It's different if they were reading quite high. Okay, well here's the neon out of its container. All I did was just filed off the 2 tabs that hold this plastic bit in. So I'll just put some silicone or some hot glue in behind that, and you can see there the wire is broken away. It's just come unsoldered, that's all. Nice easy little fix. So I'll just bear that wire back a bit, put a bit of flux on, and resolder it. Right, that's all soldered back together. The copper was a little bit corroded, so I took that white piece off. Okay, well, it's all back together. I've got it currently connected up to my variable power supply, so no voltage on it at the moment, but I want to check that this neon is working now. So again, I'm sure you've heard loads of people say it, but be aware, this is live mains voltage, and if you grab hold of it, it can kill you. So obviously we've got the primary side and the secondary side of this. This is the primary side, so we've got 240 volts on this side. I'm not sure what the output is, but we'll check that in a minute. So let's start winding it up gently. See if that neon lights. I'm up to 60 volts. 100 volts. I think that neon's lit yet? No. Just pop this on AC voltage. Make sure we have got our voltage coming through here. Okay, so that's telling me I've got 9.5 volts. That's 100.2. Let's turn that off a minute. See if this fuse is okay. Yeah. We're up to 190 volts and no LED, no neon still. That's 240 volts. Still no neon, which is a shame. Okay, well, I took my neon apart again, and lo and behold, it was it had pulled apart again. As you can see, it's now fine. There's a little flicker there, look. So the input, I'm on AC range. So we've got 235 on the input, and the output (17.8). So it's about 18 volts, I suppose, if I rammed it right up to full. Yeah, if I put it right up to 240, I expect to get 18. Let's just pop it up a little bit. So 239. (18 volts on the output. So then it goes from AC, it goes through the bridge rectifier down the bottom here, and that converts it to DC. So output wise then, this is the output. Let's go DC now. So it's doing really 5 to, it'll do 19 on full whack, but we want it set to around about 12. Because I mean, fully charged batteries would be just over 12 volts for one of these. Well, there we are. That looks to be about it. I've redone the connections on the two ends. They're all sorted and finished. Both resoldered. So I'm going to put this one back together now. Okay, well I nearly forgot the crack in this one. Down here, I think this has been dropped. You can see there's quite a big crack opens up just here where my finger is. Goes right the way down to here. So what I'm going to do is I'm going to put some epoxy in that. So I've just got some just normal 2-part epoxy here. It's not expensive stuff, it's only like from a local sort of, I don't know what you call it, Wilkinson's basically. So you just mix this up 50-50, blob of each. This is quite good for fixing plastics. It's I find it's better than super glue. Super glue's okay if you've got a dead clean break and you can get it in the crack and clamp it up quick. This has been super glued before, so it's unlikely to work in this case. So 50-50, just give it a good mix up. This is quite fast setting, but it'll need 24 hours to go off fully. So just kind of get that fuse holder out for a minute. Right, so what I want to do is just open up the crack. If you can see that or not. Just going to open up the crack and get some epoxy hopefully inside. It's actually gone down the bottom here as well. Both sides. So I'm just going to get a clamp now, just clamp that together. Okay, well that's all clamped up now. You can see that. All clamped up. I'll leave that for 24 hours and that should set rock solid. So can't quite put this back together yet. But as I say, I'll let that go off and hopefully that'll be a better job.